If you look at the word fatigue in my slide, I think the first image that you would have is exhaustion, tiredness, I'm fatigued, sort of things. But actually, fatigue also has another meaning, which is failure process due to repetitive loading. Fatigue is accounted to be the cause of more than 90% of all mechanical failures. Pretty bad, huh? That's why in the past few years, I've been working hard to establish a new method to predict the initiation of fatigue crack based on damage mechanics. Today, I'm going to present to you the gist of my PhD thesis concisely using these 9 figures within the next 2 minutes and 20 seconds. Here we go. First, we have selected automotive suspension tower, a component known to be susceptible to fatigue failure as our case study. To solve this kind of problem, we need to identify the loading which is experienced by the component. From our collaboration work with Proton, we have obtained the road test data, which reveal to us the load magnitude, its frequency, and the dominant component is vertical loading. All this information would then be incorporated into our fatigue testing plan. As for the material, we have selected dual phase steel and advanced high-strength steel, a popular material in automotive industry due to its many excellent qualities. In accordance to ASTM standard, we have conducted a series of fatigue testing to establish the material's fatigue strength database. For further investigation, we have looked deeper by monitoring what's happening inside of the material when subjected to fatigue loading. By analyzing the stress-strain hysteresis data, we have obtained several important variables such as stiffness from the slope, energy from the area, and strain range from its width. So by analyzing the stiffness data, for example, we know that stiffness is inversely proportional to damage. So if stiffness goes down, then we know that damage would evolve. Damage evolution would lead to initiation of crack, and further loading would make this crack to grow, and finally, total failure. We have verified our finding here by making an additional observation on the surface of the material, where we found micro cracks, small tiny cracks to be initiated. Relationship between number of cycles for fatigue crack initiation and damage variables was established. As the result, a new equation to predict fatigue crack initiation was derived. Finally, if we take this equation, put it into a numerical computation code, prediction of fatigue crack initiation for any component of interest would be possible, and many lives could be saved. Thank you.